All right, today we're going to review for your CU3 test. Number 1 says multiply and simplify. So what you want to do is factor every numerator and denominator and then multiply straight across the top, straight across the bottom, and cancel like factors. So my 24x minus 16, I can pull a 4 out of there. So if I pull a 4, I would have 6x minus 4. And that means I can pull an 8, actually, which would leave 3x minus 2. So the top of this I'm going to rewrite is 8 times 3x minus 2. The bottom I can't do anything with. The top I can't do anything with. And the bottom I can't do anything with. Now, we would multiply straight across the top, so I'd have an 8 times a 3x minus 2 times a 14. And on bottom I have a 49 times a 2 minus 3x. Now, these two look almost the same, except for they're backwards. When they're backwards, we use what we call the -1 trick. In other words, I could factor this. I could take my 2 minus 3x, and I could factor out a -1. And if I factored out a -1, that would make -2 plus 3x. And since addition is commutative, I can rewrite this as 3x, positive 3x minus 2. So I'm going to rewrite this one. So I have 8 on top times 3x minus 2 times 14. On bottom I have 49 times -1 times 3x minus 2. So now we can see that we can cancel the 3x minus 2's. And as far as the numbers go, the 14 and the 49 have a 7 in common, so 7 goes into 14 twice, and 7 goes into 49 7 times. So now on top I have 16 over -7, which makes it a -16/7. Okay. All right. Same directions, so I'm going to factor this. It should be an easy factor because a is 1. So x times x is x squared. Factors of 18 that make 9 would be 6 and 3. Since c is positive, they both get the middle sign. So I can refactor the top, or rewrite the top as factors, x minus 6 times x minus 3. Then we're going to factor this, the x squared minus 25, that's difference of squares, so bino, plus and minus. The square root of x squared is x, the square root of 25 is 5. So the top of that one, and again we're multiplying, so it's straight across the top, straight across the bottom, so that's going to be x plus 5 times x minus 5. The bottom, the x squared minus x minus 30 should be an easy factor because a is 1. So x times x, factors of 30 that make 1 would be 5 and 6. Since c is negative, only the bully gets the middle, and he doesn't. So I can rewrite that as x plus 5 times x minus 6. And then finally, oops, I already used green. The bottom of this one, x squared minus 9, is difference of squares, so bino, plus and minus. Square root of x squared is x, square root of 9 is 3. So I can rewrite that as x plus 3 times x minus 3. So I factored everything and not combined, but put the factors on top together, put the factors on bottom together, so now I can cancel. The x plus 5's cancel, the x minus 6's cancel, the x minus 3's cancel. So what I'm left with on top is x minus 5, and on bottom is x plus 3. Okay? Alright, we've got division, which means we keep, change, flip, and I'm going to factor as I go. So if I factor the top of this one, 3b minus 12, I can GCF a 3 out, which would leave b minus 4. So I rewrite the top as 3 times b minus 4. The 35 I can't do anything with. I'm going to change to multiply, but I got to flip these guys. So that goes on top, that goes on bottom. So if I can't factor that, but that's got to move to the bottom. And I can't factor that, but that's got to move to the top. Okay, so now we can cancel. The v minus 4's cancel. 7 will go into 35 and 49. 7 goes into 49 7 times. 7 goes into 35 5 times. So on top you have 3 times 7, and on bottom you have 5, which makes 21 over 5. Alright, add or subtract is indicated. To add or subtract, you have to have a common denominator, which means I've got to factor everything, or I'm going to get really, really, really huge polynomials that are not going to be fun to combine. So I'm going to factor this. X squared minus 64 factors into bino, plus and mino. Factors are the square root of x squared is x, square root of 64 is 8. So I can rewrite that top one as x plus 8 times x minus 8. Plus, if I factor this bottom, should be an easy factor because a is 1. So x times x. Factors of 64 that make 16 would be 8 and 8. Since c is positive, they both get the middle. So I can rewrite that bottom as x minus 8 times x plus 8. Minus 8 minus 8. Okay, and then we have the last one, which I can't factor, so it's just going to stay x plus 8. So now what I have to do is I have to rewrite these denominators as the same denominator. So what I need to do is figure out my common denominator, which this denominator says I need a 1 copy of x plus 8 and 1 copy of x minus 8. This denominator says I need 2 copies of x minus 8. Well, I already have 1, so I need another. And this says I need a copy of x plus 8, which I already have. So that would be my common denominator. This one has the x plus 8 and the x minus 8, so it's missing another x minus 8. So I multiply the top and the bottom by x minus 8. This one has both the x minus 8s, it's missing an x plus 8. So I'm going to multiply the top and the bottom by x plus 8. This one has the x plus 8, it's missing both the x minus 8. So bottom and top by x minus 8. So now you can see that all of my denominators look like that. Maybe in a different order, but they all look like that. Okay? So now on top of the first one, I'm going to have x squared minus 8x. In the middle, I'm going to have 9x plus 72. And on the last one, I'm going to do it up here. I'm going to have x squared minus 8x plus 64. And then I have to subtract all of that, which this would be x squared minus 16x plus 64. But again, I have to minus that, so that's going to be minus x squared plus 16x minus 64, because I have to distribute the negative. Oops. Where did it go? Sorry. So as I have to distribute the negative. Okay? So now on top, we're going to combine like terms. This x squared cancels this x squared. And let's see, I have a negative 8x plus 9x plus 16x. So if I do negative 8 plus 9 plus 16, I get 17. Yeah, because that'd be 1 plus, yeah, that's right. So 17x, and then I have 72 minus 64, which would be positive 8. And on bottom, I have x plus 8 times x minus 8 squared. and I can't factor this, and I guess which wouldn't factor into one of these anyway to cancel, so I am done. All right, this one is a complex fraction. I don't know why that's there. Why isn't that going away? Hold on just a second. There we go. Okay, so now we have what we call a complex fraction, where we have to simplify the top, simplify the bottom, and then we can keep change flip. I can't keep change flip yet because we have a sum of fractions on the top and a difference of fractions on the bottom. So if we do the top and the bottom separately, on top, I have 1 over a plus 1 over b. If I make a common denominator, that would be an a times a b. This one has the a, it's missing the b. This one has the b, it's missing the a. So on top, I have b plus a. There's my top. Okay, b plus a over ab. Bottom, purple. I have 1 over a squared minus 1 over b squared. So I need a common denominator, which is going to be a squared times b squared. This one has the a squared, it's missing the b squared. This one has the b squared, it's missing the a squared. So my new tops become b squared minus a squared. So there's my bottom, but I can factor this. That's going to be b plus a times b minus a, difference of squares, over a squared, b squared. So now that I have the top and the bottom simplified into one fraction over one fraction, I can actually keep change flip now. So I'm going to keep the top, which would be b plus a over ab. I'm going to change to times, and I'm going to flip the bottom, which would be a squared b squared over b plus a times b minus a. And now I'm back to multiplying, so straight across the top times straight across the bottom, and now I can start canceling. The b plus a's cancel. Now these are both monomials. This one copy of a on bottom is going to get rid of one of the two on top. This one copy of b is going to get rid of one of the b's on top. So now what's left is ab over b minus a. Okay. All right, it says find the domain of the function, use limits to describe the behavior of f at values of x naught in its domain. Okay, so when we do domain, we say, Mr. Denominator, you can never equal 0. So solving this, I would add 16, x squared can never equal 16, square root, x can never equal plus or minus 4. So there's my domain. It's a set of all real numbers except for -4 and 4. And so now if I graph this, and I should have already had a picture of that. Sorry. Okay, I'm typing it in my graphing calculator right now. So I got -1 divided by x squared minus 16. And if I hit graph, I end up with, get a better picture here. At 1, 2, 3, 4, 1, 2, 3, 4, -4 and 4, there are asymptotes, and this thing, sorry, I should have had this done ahead of time. This thing does this. Bloop. Bloop. Can't really tell what it's doing there. Looks like it's doing this. Bloop. And bloop. Okay, so this is what it's looking like. So it says find the limit as x approaches -4 from the left. Okay, so here's my -4, left side, right side. So on the left side, the tail closest to the red line is pointing down, which means it goes to negative infinity. Okay, on the right-hand side, we're approaching -4 from the right, and if I look at the arrow closest to the right-hand side, it's pointing up, which means the limit is going to positive infinity. Okay, and as I approach 4 from the left, let me make that a different color. Green. There's my +4, there's the left, there's the right. On the left-hand side, closest to the asymptote, it's pointing up, which means it's going to infinity. And as I approach 4 from the right, here's the right-hand side. The tail closest to the right-hand side of that green line is pointing down, which means it's going to negative infinity. All right. So it says, describe how the graph of the function can be obtained by transforming the graph of the reciprocal function 1 over x. Identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. Sketch the graph of the function. Okay, so remember, when there's not a variable on top, that -4 is going to shift it 4 units to the right. That 2 on top is going to be your vertical stretch. So I'm wanting 1 shifted right 4 and stretched vertically by 2. Okay, the vertical asymptotes you get by setting denominator equal to 0, which would give me x equals 4. Okay, and then your horizontal asymptotes, you use your degree rules. My top degree is 0 because there's no x. My bottom degree is 1. So my top degree is smaller than my bottom degree, which puts me a horizontal asymptote at y equals 0. All right, so then we would type it in the graphing calculator and we get this. Okay, and I must have not copied all of this because they want the limits to describe the corresponding behavior. I apologize, there must be more to this problem that I didn't scroll down and get. Anyway, we can still do that even though we can't see the answer. So we have limits. Okay, first of all, we're going to have our end behavior, which we know is going to follow our horizontal asymptote. So the limit as x approaches negative infinity, if you look at that, if you see this little, there's my horizontal asymptote. Okay, I'm going to try and draw this. This thing is doing this and this. So as I head towards negative infinity, the yellow line is getting closer and closer to the black line, which was y equals 0. Let me make it green so it matches this. Okay, it's getting closer and closer to the green line, so my function is approaching 0. And it's going to be the same thing on the other side because it's the end behavior, and the end behavior follows the horizontal asymptote. So as I go to positive infinity, again, my function is getting closer and closer to that green line. So it's approaching 0. So there's my end behavior. Now we have to do asymptote behavior. I mean, I don't know if they're really going to ask you for that, but so if I'm looking at that red line, which is x equals 4, okay, here's the left side, here's the right side. So the limit as x approaches 4 from the left, on the left-hand side, that arrow is pointing down, so my function goes to negative infinity. And the limit as x approaches 4 from the right-hand side, arrow pointing up, my function goes to positive infinity. And what else did it want? So sketch the graph. We got the graph. All right. Number 8, it says describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function. Since there is a letter on top, we have to do long division. So I have x plus 2 goes into 3x plus 7. Going to the alley, 3x divided by x is 3, so I go up 3. 3 times x is 3x. 3 times 2 is 6. Draw the line, change the signs. The x's cancel, and I get a remainder of 1. So I can rewrite this as 3 plus 1 over x plus 2. So what that means is we're going to go left 2, and we're going to go up 3. Okay? The vertical stretch would be 1. Yeah, that's it. They didn't ask for that, but there's it. Okay, so it says find the horizontal and vertical asymptotes. And again, I must not have... This question is complete. Then it says use limits to describe the corresponding behavior. I don't know why that isn't part of the answer unless I didn't go far enough. Anyway, all right, so horizontal and vertical asymptotes. For vertical, we set denominator equal to 0 and solve it, minus 4. X squared equals negative 4, square root, x equals plus or minus 2i. So since the only vertical asymptotes are imaginary, there are none. Horizontal asymptotes, you look at degrees. My top degree is 2. My bottom degree is 2. It's a tie, so my horizontal asymptote is my top leading coefficient, which is 3, and my bottom leading coefficient, which is 1, which gives me a horizontal asymptote at y equals 3. Okay, and then again, I don't know if I just didn't scroll down, and because it's saying use limits to describe, but that isn't on there. Anyway, if you did, you would graph it. So I have 3x squared plus 5, and I apologize again, I should have had this done, divided by x squared plus 4, graph. So we have no horizontal asymptotes, and let's see, we are going to go, where am I? Looks like we're going up 1, and it does this. Bloop. Bloop. Okay, so my end behavior asymptote is going to be, there's my 3. Okay, so my end behavior asymptote, we know that it's going to approach the end behavior asymptote, which is the horizontal asymptote. So the limit as x approaches negative infinity, the function is going to approach 3. It's getting closer and closer to that purple line. Oops. Okay, and the limit as x approaches positive infinity, the function again is going to approach 3. As I head this way, that arrow is getting closer and closer to that purple line, which is at 3. Alright. Vertical asymptotes, domain, x and y intercepts, then graph. Vertical asymptotes, you set denominator equal to 0, so x equals negative 3. The domain of the function, well, if we look at the graph of it, okay, and we have an asymptote at negative 3, they're counting by 2, so there it is. Okay, and so my domain, you can see there's graph, stop, graph. So that's going from negative infinity to negative 3, stop, make a union, start at negative 3 again and go to infinity. Okay, or you could have just said for here, because that's also your domain, if x can't be negative 3, it can be everywhere else, which is negative infinity to negative 3, union negative 3 to infinity. Okay, the x-intercepts, they gave you 1, you have to get the other. To get your x-intercepts, you set your numerator equal to 0 and solve. So I have x squared minus 9x plus 18 equals 0. Should be an easy factor, because a is 1. X times x, factors of 18 that make 9, 6 and 3. C is positive, so they both get the middle, which means x equals 6 and x equals 3. Now, as x-intercepts, you get x-intercepts when y is 0. So those are my two x-intercepts. To get my y-intercept, you find f of 0, which would be 0 squared. Sorry, I should probably label this. This is for x-intercepts. This is for the y-intercept. So 0 squared minus 9 times 0 plus 18 over 0 plus 3. That's 0, that's 0, that's 18 over 3, which is 6. So it's going to cross at 0, comma 6. Okay? You can see that it did. Alright. Find all asymptotes, x-intercepts, and y-intercepts for the graph of the rational function. So again, for my vertical asymptotes, we are going to set denominator equal to 0 and solve it. This should be an easy factor. A is 1. Factors of 9 that make 6 are 3 and 3. Since C is positive, they both get the middle, which means x equals 3 and x equals 3. So the equation of the vertical asymptote is x equals 3. Okay, to get my horizontal asymptotes, I do degrees. My top degree is 1. My bottom degree is 2. Top degree is smaller than bottom degree, so my horizontal asymptote's at y equals 0. The x-intercepts, you set your numerator equal to 0, so x equals -1, which as an ordered pair is -1, 0. And to get my y-intercept, I find f of 0, which would be 0 plus 1 over 0 squared minus 6 times 0 plus 9. That's 0, so that equals 1/9. And as an ordered pair, that's 0, comma 1/9. And then if you type it in the graphing calculator, you get that picture. Okay? Alright, find the intercepts and asymptotes. Use limits to describe the behavior of the vertical asymptotes and analyze and draw the graph of the rational function. Alright, so we have to find, what do they want first? The x-intercepts? Oh, they want them all. X-intercepts and y-intercepts. Okay, so to get my x-intercepts, I set my numerator equal to 0 and solve. It should be an easy factor. Factors of 2 that make 1 are 1 and 2. Since C is negative, only the bully gets the middle, which gives me x equals 1 and x equals -2. So 1, 0, -2, 0. To get my y-intercept, I find f of 0, which would be 0 squared plus 0 minus 2 over 0 squared minus 49. And that would be positive 2 over 49. So that ordered pair would be 0, comma 249. Alright, vertical asymptotes. To find vertical asymptotes, we set denominator equal to 0 and solve. Add 49. X squared equals 49. Square root x equals plus or minus 7. To get my horizontal asymptotes, I look at my degrees. My top degree is 2. My bottom degree is 2. They're equal, so my horizontal asymptote is top leading coefficient divided by bottom leading coefficient, which is 1. So y equals 1 is my horizontal asymptote. Type it in the graphing calculator and you get this picture. Okay? And remember, we have asymptotes at -7 and at +7. Okay? So, and that graph is not very easy to read. Let me make it a little bigger. 7, -7, and what's my horizontal? Y equal 1. So this thing does this. Parabola's in the middle, and this on the end. So, to do my limits around the vertical asymptotes, let's do -7 first. Here's the left, here's the right. The limit as x approaches -7 from the left side of the red line is pointing to positive infinity. And as it approaches -7 from the right, here's the right side, the arrow closest on the right side is this one. which is pointing to negative infinity. If I approach 7 from the left, again, let me make this one green. This is I approach the grid. This is left, this is right. The left side of positive 7 is pointing down, so that's negative infinity. And the right side of that green line is pointing up, so that's going to positive infinity. Alright, number 13. Find the intercepts and asymptotes, use limits, so same directions. Alright, so to find my x-intercepts, I set my numerator equal to 0. Should be an easy factor. 9 and 7 make 63 if I multiply, and 2 if I subtract. So since c is negative, only the bully gets the plus and 7 doesn't, which gives me x equals negative 9 and x equals 7. So those two ordered pairs would be negative 9, 0 and 7, 0. To get my y-intercept, I find f of 0, which would be 0 squared plus 2 times 0 minus 63 over 0 plus 2. That's 0, that's 0. And I get negative 63 over 2. So that ordered pair would be 0, comma, negative 63 over 2. Okay. Vertical asymptotes. We set denominator equal to 0. It can't be 0, so, well, is 0. So x equals negative 2 is my vertical asymptote. My horizontal asymptote, we look at degrees. My top degree is 2. My bottom degree is 1. Top degree is bigger than bottom degree, so there is no half. Okay, and if we type it in the graphing calculator, we get this, because it's going to follow some sort of slant asymptote, which they didn't ask me to find. Okay, so there would be the graph. Alright. Same directions and behavior asymptote. Okay, so we want the intercepts. To get my x-intercepts, we set numerator equal to 0, so I have x to the 4th equals negative 4. Take the 4th root. Because you're taking the 4th root, that's not going to be real. Those are going to be imaginary. So there are no x-intercepts. To get my y-intercept, I find h of 0. 0 to the 4th plus 4, 0 plus 1, that's 4 over 1, which is 4. So my only intercept is, y-intercept is 0, 4. Vertical asymptote, a different color here. Vertical asymptotes, we set denominator equal to 0, so x equals negative 1 is my vertical asymptote. For my horizontal asymptote, my top degree is 4, my bottom degree is 1, top degree is bigger than bottom, so there's no half, which means there's going to be a slant asymptote, and the way you find it is you divide. So I have x to the 4th plus 4 divided by x plus 1. And I better give myself some more room. Oops. So I'm going to have x to the 4th plus 4 divided by x plus 1. So x to the 4th divided by x is x cubed, times x is x to the 4th, times 1 is x cubed. Draw the line, change the signs, the 4th degrees cancel, and I have negative x cubed plus 4, because you can't combine those. And I go again. Negative x cubed divided by x is negative x squared, times x is negative x cubed, times 1 is negative x squared. Draw the line, change the signs, the cubes cancel. I get x squared plus 4. Divide again. X squared divided by x is x, times x is x squared, times 1 is 1x. Draw the line, change the signs, the squares cancel, and I have negative x plus 4. Divide again. Negative x divided by x is negative 1. That's negative x minus 1. Draw the line, change the signs, the x's cancel, and I get a remainder of 5, which I don't care about. This is going to be my end behavior asymptote. Okay? This is where they got that. And then if you type it in the graphing calculator, there's your function. And you can see that the blue, that's the end behavior asymptote. Those parabola thingies, you can tell they're following that asymptote. Alright. This one says solve. We have equations, so yay, we are allowed to kill. So I have x plus 9 over x equals negative 10. To get rid of that dividing by x, I'm going to multiply by x. This is the only one that dies. The rest are going to multiply. That gives me x squared plus 9 equals negative 10x. Fractions are dead, so now we solve. I got to get 0 on one side, so add 10x. And that gives me x squared plus 10x plus 9. Should be an easy factor. A is 1. X times x. Factors of 9 that make 10 are 1 and 9. Since c is positive, they both get the middle, so they're both positive, which gives me x equals negative 1 and x equals negative 9. As long as I don't violate my restrictions. None of my denominators can equal 0. So as long as I don't get 0 for an answer, I can keep them. And we're done. Alright, so again, we're going to solve this one. The trick here is factor anything that you can so that you don't multiply by too much. And this one I can factor. So I'm going to rewrite it. I got 7x over x plus 7 plus 1 over x minus 3 equals 10 over, should be an easy factor, x times x. Factors of 21 that make 4 would be 7 and 3. C is negative, so only the bully gets the middle, and 3 doesn't. Okay, so now I'm going to multiply by one of every factor in every denominator. So multiplying by an x plus 7 will get rid of that one and the one on the end. Multiplying by an x plus minus 3 is going to get rid of this one and this one. And I've got everything colored and covered. So we're ready to die and multiply. Here, the x plus 7's cancel, so I'm left with 7x times x minus 3. Here, the x minus 3's cancel, which leaves me with a positive 1 times x plus 7. And here they both cancel, which leaves me with just 10. So the fractions are dead. So now I need to simplify and solve. So I have 7x squared minus 21x plus x plus 7 equals 10. Combine like terms. I have 7x squared minus 20x plus 7 equals 10. I need to get 0 on one side, so minus 10 minus 10. I get 7x squared minus 20x minus 3 equals 0. And now, I'm going to write that up here. This one is not an easy factor. I'm going to have to rewrite b. 7 times 3 is 21. Factors of 21 that make 20 would be 1 and 20. 1. Yeah? So, they're going to be x's. And since c is negative, only the bully gets the middle. So 21 is minus, 1 isn't. So I'm going to have 7x squared plus 1x minus 21x minus 3 equals 0. So I rewrote b. 2 by 2, GCF, GCF, GCF again. Woo! On the left side, the only thing I can take out is an x. If I divide x out, that leaves 7x plus 1. On this side, I can divide out a 3. And I'm always going to take the first guy's sign, so I'm going to take the negative. And if I divide by -3, I get positive 7x plus 1. GCF again by your matching bino. Oops. And you should get 7x plus 1 times x minus 3 equals 0. Alright, and solve 7x plus 1 equals 0, x minus 3 equals 0. And I'm sorry, I should back up and go get my restrictions. This says that x plus 7 can never equal 0, so x can never be -7. This says x minus 3 can never be 0, so x can never be 3. And this says, since in factored form, that x can't be -7 or 3. So we've already got those restrictions. So as long as I don't get -7 or 3 for answers, my answers are going to be good. Alright, so minus 1, 7x equals -1, divide by 7, divide by 7. X equals -1/7, add 3, x equals 3. 3 is one, not being 3 is one of my restrictions, so that one I have to throw away. That wasn't one of my restrictions, so my solution is -1/7. Alright, more of the same. Again, I'm going to factor where I can. I can't factor the top, it's a monomial. The bottom is degree 1, it's prime. Bottom degree 1, it's prime. Bottom, I can factor out a z, which would leave z plus 2. Okay, so now I need to kill all my fractions. So I need to kill the z plus 2. Oh, and don't forget him, even though he's not a fraction, he gets everything. That gets rid of, that kills any x plus 2 in denominators. There's a z also, so I gotta multiply by a z to kill it. And that'll kill them both. So I've got everything colored and covered. So now it's time to die or multiply. And here the z plus 2's are going to cancel, which leaves me 4z times z, which is 4z squared. The z cancels, that leaves me with 8 times z plus 2. Nothing cancels, so that leaves me 3 times z plus 2. I can multiply in any order I want. And they both cancel over here, which leaves me with 16. So now we're going to simplify and solve. Distribute. I have 4z squared plus 8z plus 16 plus 3z squared plus 6z equals 16. So now I'm going to combine like terms. 4z squared and 3z squared is 7z squared. 8z and 6z is 14z. And plus 16 equals 16. So now I'm going to get 0 on one side, minus 16, and it cancels on both sides. So I got 7z squared plus 14z equals 0. Two terms are easy to factor, and I apologize, I should go back and do my restrictions. Z plus 2 can never equal 0, so z can never equal -2. And this one says that z can never equal 0. And this one says, in factored form, that z can't be -2 or 0, which I already have. So if I get either of these for answers, I have to throw them out. Alright, factoring two terms is easy breezy because it's GCF times what's left. That's pretty much all you can do with two terms, unless it's one of your specials. These guys have a 7z in common. If I divide by 7z, I get z plus 2. So now if I solve, I get 7z equals 0 and z plus 2 equals 0. Divide by 7, z equals 0, but that's one of my restrictions, so I have to throw it out. And so solve this one, z equals -2, which is this restriction. So I have to throw it out. Since I threw all of my answers out, there's no solution. Alright, it says the two possible solutions to the equation f of x equals 0 are listed. Use the given graph of y equals f of x to decide which, if any, are extraneous. x equals negative 5 or x equals negative 4. When you're doing this, you go look at the graph. If I go to negative 5, and is there a point on the graph above it? Yeah? So that's a solution. Okay, and then negative 4, why is negative 4 extraneous? There's a point on it. Huh. Why is negative 4 extraneous? I'm not really sure why negative 4 is an extraneous solution. I think that's an error. Extraneous would be like at f0, like if they got 0 for an answer. That's not true because there's an asymptote there. There's no point on the graph. I'm not really sure how we're supposed to know that's extraneous if I can't see a hole or an asymptote there. I'm not sure about that one. I'm going to have to check. Alright. 19. It says solve the equation algebraically. So more of the same. We have 4 over x minus 1 plus x equals 7. The only denominator that I have to get rid of is dividing by x minus 1. So I have to multiply everything by x minus 1 to kill it. It dies. I'm left with 4 plus x times x minus 1 equals 7 times x minus 1. So if I clean this up, distribute, I have 4 plus x squared minus x equals 7x minus 7. It's quadratic, so I need to get everything on the same side, so I'm going to minus 7x to get rid of it, and I'm going to add 7 to get rid of it. And I'm going to put it in order, so I have x squared minus 8x plus 11 equals 0. And if I tried to factor this, there's no factors of 11 that make 8, so I'm going to have to do quadratic formula. Negative b, give me that, it's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to give me 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 11. You get the square root of 20 all over 2. If I break down 20, by 2 is 10, by 2 is 5, I get a perfect 2. Square roots of 5. So I have x equals 8 plus or minus 2 square roots of 5 over 2. Reduced by 2, I get 4 plus or minus the square root of 5 over 1. So my two solutions are 4 plus the square root of 5 and 4 minus the square root of 5. And my only no-no would have been if I got 1, because x can never equal 1. Alright. Electrical resistance R of two resistors connected in parallel with resistances R1 and R2 is given below. It says one resistor has a resistance of 2.5 ohms. Let X be the resistance of the second resistor. Express the total resistance R as a function of X. Well, it's saying that 1 over R equals 1 over R sub 1, which they gave me. One of them is 2.5, plus 1 over R2, which I don't know. So we can call that X, I'm assuming. Okay, so now we've got to get a common denominator. which is going to be 2.5 times x. This has the 2.5, it's missing x. This has the x, it's missing the 2.5. So that's going to be plus 2.5, and that's where they got this. Okay, and then it says the resistance of the second resistor is approximately what? Oh, I'm sorry, I didn't read. Okay, so B says find the resistance of the second resistor if the total resistance of the pair is 1.4 ohms. And that would be where I plug it in right here. So I have 1 over 3.18 equals x plus 2.5 over 2.5x. So now we have a proportion. I mean, we could kill the fractions if you want, but multiply down is 2.5x equals 3.18 times x plus 2.5. Simplify this, I have 2.5x equals 3.18x plus 3.18 times 2.5 is 7.95. So now if I want to get x alone, I'm going to do negative 3.18x oh my gosh, Tamsin, I'm sorry, I'm reading the answer and I'm supposed to plug in 1.4 there. Oh goodness, gotta love Hammy. I'm sorry. That's what I get for looking at the answer. The total resistance is 1.4. That's what goes here, is the 1.4. So that's going to be 1.4 times x plus 2.5. So we got 2.5x equals 1.4x plus 1.4 times 2.5 is 3.5. I knew I screwed up because I was going to get a negative answer, and that would not make any sense in the context of this problem. Alright, so I'm going to get my x's together now. So minus 1.4x minus 1.4x. 2.5 minus 1.4 is 1.1x equals 3.5. Divide by 1.1 and I get x equals 3.5 divided by 1.1, hopefully 3.18181818, which is why they just marked it off at 3.18. Alright. 21. It says, a swimming pool can be filled in 14 hours if water enters through a pipe alone, or in 23 hours if water enters through a hose alone. If water is entering through both the pipe and the hose, how long will it take to fill the pool? Well, the hose alone, or the pipe alone, can fill 1/14 of the job per hour. Okay? And for the hose, it can fill 1/23 of the pool per hour. And if they're working together, that's got to add up to one full pool. It's got to add up to one full job, meaning the pool is full. Okay? So this would be the same thing as x over 14 plus x over 23 equals 1. I have to get a common denominator, which is 14 times 23. Okay, this one, the first one has the 14, it's missing the 23. So that would put my top at 23x. This has the 23, it's missing the 14, which would put this at 14x. So now if I simplify that, 23 and 14 would be 37x. Over 14 times 23 is 322. So now to solve this, I'm going to kill the fraction, so I'm going to multiply both sides by 322. I get 37x equals 322. Divide by 37, and x equals 8.7027, yada yada yada. Let's call it 8.7. Except for your lovely friends gave it in a mixed number. I don't really know how you're supposed to know that from simplify your answer, but you know what you have to do on this is, at least with the calculator, you know that it went 8 whole times. 8 times 37 is 296. 377 minus 296 is 81. So I have, it's not 81. $322. Townsend, good grief. 322. 37 times 8 is 296. 322 minus 296 is 26. That's better. So I have 8 and 26 over 37 is how they ended up with that. Alright. It says determine the x values that cause the polynomial function to be 0, positive, and negative. What you do, if it's already in factored form, that is nice for me. So I have x plus 9, I'm going to get my zeros. X plus 9 equals 0, x plus 2 equals 0, x minus 7 squared equals 0. So this one's going to give me x equals negative 9. This one's going to give me x equals negative 2. Square root both sides, I get x minus 7 equals 0, so x equals 7. But that's going to be multiplicity 2. And at any rate, what you do to figure out where it's positive, negative, 0, positive, and negative, you're going to be 0 here, here, and here at x equals negative 9, negative 2, and 7. Okay? Now, where the function is positive, and again, I'm cheating here. I just graphed on the type graphing calculator, so you can see here it's positive, here it's positive, and here it's positive. And here is negative. Okay? So what you're supposed to do, and I don't mind if especially in a test situation, if you cheat, but what you're supposed to do is put negative 9, negative 2, positive 7, and then you pick points and you test them. So down here I'm going to pick negative 10. So if I find f of negative 10, I'm going to have negative 10 plus 9, negative 10 plus 2, negative 10 minus 7 squared. This is going to be negative 1. This is going to be negative 8. This is going to be negative 17 squared, which is going to be positive something, and I don't really care what the number is. You're going to have a negative times a negative is a positive, times that positive is going to be positive. So this section of number line is positive. Now I'm going to pick something between negative 9 and negative 2. How about negative 3? And if I plug that in, negative 3 plus 9, negative 3 plus 2, negative 3 minus 7 squared. This is going to be a positive, this is going to be a negative, this is going to be a negative squared, which is going to be positive. The positive times a negative is a negative, times a positive is a negative. So this section of number line is negative. And again, guys, remember, unless you have multiplicities, pretty much once you find one sign, it alternates. This one's going to be a little different because you got that multiplicity of 2, which means it's tangent right there and it touches and turns instead of goes through. People get real lazy on these and they just find one and then they start alternating. Okay? And you got to watch those multiplicities. Alright, so I'm going to pick something between negative 2 and 7. Anytime I can pick 0, I'm picking 0 because that makes math easy. If I find f of 0, I'm going to have 0 plus 9, 0 plus 2, 0 minus 7 squared. This is going to be positive. This is going to be positive. That's a negative. Squared is a positive, so this section is going to be positive. And if I pick something after 7, like 8, and I find f of 8, I would have 8 plus 9, 8 plus 2, 8 minus 7 squared. This is a positive, 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 which makes this section positive too. And again, because of that multiplicity, that's why you didn't have a sign change there. Okay, so now all you do is you describe where it's positive and where it's negative. So here they're looking for where it's positive. So that's this section, and this section. Now you can't include the 7 because 7 is a 0 and 0 is neither positive nor negative. So if I'm describing what I highlighted in yellow, where it's positive is, and I don't like this, I thought they were doing interval notation. Interval notation is positive from negative infinity to negative 9, union, negative 2 to 7, union, 7, what the heck, 7 to infinity. Dang it, this thing has a mind of its own. Okay, but the way they do it is they say this section would be x is less than negative 9. That's where they got this. Anytime they have a break, instead of putting this union, they put the or. And then this section, you can see, is x. This section is between negative 2 and 7. Right? Dang it. Alright, and that's where they get this. And then this says that x is greater than 7. I'm going to switch on me. Alright, that's where they got this. And then the negative, there's only one. Oh, there's B and D. I'm like, where the heck is the answer? That's not either one of them. Never mind, I didn't see they had them over here. Okay, so your negative section is right here. And that is between negative 9 and 2. So you say it's negative between negative 9 and negative 2. That would be how they wrote it. Interval notation, we would say it's from negative 9 to negative 2. Okay? Alright. Determine the x values that cause the polynomial function to be 0, positive, and negative. If, to get our zeros, we set each factor to 0 and we solve. And watch your multiplicities. Okay, so on this one, minus 2, 9x squared equals negative 2, divide by 9, x squared equals negative 2/9, square root, and you get x equals plus, or you're going to get imaginaries, so you aren't going to get any intercepts out of that. Okay, square root, I get x minus 8 equals 0, so x equals 8, multiplicity 2, which means it's going to be tangent there. So you get the 8, 2, 4, 6, I'm counting by 2s, it touched and turned. Okay, this one, cube root, x plus 7 equals 0, minus 7, x equals negative 7. This has multiplicity 3, which means it's going to pass through. But see how it kind of flattened out right there too? That's how come I knew that it wasn't just a 1, it was, well, I knew it was 3 because they wrote a 3. Alright, so my zeros are at 8 and negative 7. There's my zeros. Okay, now again, if I plot those, there's my negative 7, there's my positive 8, we're going to test. So I'm going to pick something below negative 7, I'm going to find f of negative 8. So I would have 9 times negative 8 squared plus 2. Oops, I'm putting in negative 7, Dippy. No, I'm putting in negative 8, my bad. Negative 8 minus 8 squared, negative 8 plus 7 cubed. This is going to be a positive times 9 is a positive, that's going to be positive. This is a negative squared is going to be positive. This is a negative cubed, which is going to be negative. A positive times a negative is a negative. So it's going to be negative over here, and you can tell that it is. Okay? Next, I'm going to do something in between. Gotta love 0. So I'm going to have 9 times 0 squared plus 2. 0 minus 8 squared. 0 plus 7 cubed. That's 0 plus 2, that's a positive. Negative squared is going to be a positive. Positive cubed is a positive. So this section is going to be positive. And you can see all of this is up in the air until you get over here. Okay, so I'm going to pick something beyond 8, like 9. So if I do f of 9, somewhere, I have 9 times 9 squared plus 2. 9 minus 8 squared, 9 plus 7 cubed. That's a positive times a positive plus a positive is positive. That's positive 1 squared is positive. Positive cubed is positive. So this section is also going to be positive. And again, that's because of that even multiplicity it touched in turn. So what values, now they're doing it in rotation, what values make your function positive? Well, it's positive from here to here. Sorry, I didn't mean to draw through that. You got to skip that. So we would say that it is positive from negative 7 to 8, union 8 to infinity. And it's negative in this section, which would say negative infinity to 7, to negative 7. Okay? Alright. Factor the polynomial and solve the inequality using a sign chart support graphically. If it says factor, then it's supposedly factorable. So, when there's 4 terms, my technique is going to be 2 by 2, GCF, GCF, GCF again. Woo! So this side, I can pull an x squared. If I divide by x squared, I get 4x minus 3. This side, I can divide by 4, and I'm going to use a negative. Divide by negative 4, divide by negative 4, I get positive 4x minus 3. My matching bino is 4x minus 3 times x squared minus 4. So I factored it. Now to solve it, I have 4x minus 3 equals 0. Add 3. Divide by 4, I get x equals 3/4. X squared minus 4 equals 0. Add 4. Square root, x equals plus or minus 2. Yes? Alright, so on my number line, I have at 3/4 and at 2 and negative 2. And we need to do a sign chart. So I'm going to pick something below negative 2, like negative 3. And that would give me 4 times negative 3 cubed minus 3 times negative 3 squared minus 16 times negative 3 plus 12. This is going to be a negative times a positive is negative. Oh, I guess I'm going to have to figure that out, huh? So if I just type this all in, left to right, I'm going to have 4 parentheses negative 3 cubed minus 3 parentheses negative 3 squared minus 16 parentheses negative 3 plus 12, I get negative 75. So this section is negative. If I pick something between negative 2 and positive 3/4, and I'm going to go for 0, it makes life easy. F of 0 would be 4 times 0 cubed minus 3 times 0 squared minus 16 times 0 plus 12. Those are all 0. It's positive 12, which means this section is positive. And notice how I didn't have any multiple roots. I didn't have any multiplicities. So, and again, if you notice, negative, positive, negative, positive. and it's alternating. But we should still check. Something between 3/4 and 2, 1 would be good. So if I find f of 1, I would have 4 times 1 cubed minus 3 times 1 squared minus 16 times 1 plus 12. That would be 4 minus 3 minus 16 plus 12. Minus 3 minus 16 plus 12. You get negative 3, which is negative. And if I pick something beyond 2, like 3, I'd have 4 times 3 cubed minus 3 times 3 squared minus 16 times 3 plus 12. And 4 parentheses 3 cubed minus 3 parentheses 3 squared. Minus 16 times 3 plus 12, I get 45, which is positive. Okay, now what they want to know is, when is this thing positive? Because they're asking me, when is it greater than or equal to 0? Well, that's between negative 2 and 3/4. I don't know why they're using square brackets. Negative 2 is a 0, it's not included. Negative 2 to 3/4 union, and it's positive here, which is 2 to infinity. Again, I'm not sure why they're using the, oh, I do, there. You see where it says greater than or equal to? So they're saying, again, normally we would put round ones, but it's saying or equal to, so you're including the zeros, which means the zeros get square brackets. See how sometimes seeing the answer makes you think about why? Even me. Okay, solve the polynomial inequality graphically. So they're telling me to solve it graphically, they're telling me to plug it into the graphing calculator. And what I did was I found this 0, which is at negative 1.24. I just calculated it on the calculator. And then from the graph, so that would be my only 0, negative 1.24. And I basically have to check both sides of this. I mean, yes, I can see from my graph that this side is going to be negative and this side, actually I don't have to check it because it said I could do this graphically. So yeah, this side is negative and this side is positive, and they want to know, when is it greater than or equal to 0. So that's this section, but it's including the 0, so it's going to start at negative 1.24 and go to infinity. Alright, determine the real values of x that cause the function to be 0, undefined, positive, and negative. Alright, so to get your zeros, you set numerator equal to 0, which is when x equals 1. Okay, so on my number line here, on 1, that's going to be a 0. I'm going to mark it with a Z. Okay, so gosh, you guys, I'm so very sorry. I copied, you can see C and D here. You can't even see all of C. Okay, you can't see the answers because I'm a schmo, and when I copied and pasted, I cut everything off. I apologize. So for A, the function is going to be 0 at x equals 1. Okay, for B, they want to know when it's undefined. It's going to be undefined when my denominator equals 0. So if I solve that, 3x plus 5 equals 0, x minus 8 equals 0, subtract 5, divide by 3, you get x equals negative 5/3, add 8, I get x equals 8. So it's going to be undefined at negative 5/3, I'm going to put a u there, and at positive 8. Those are your asymptotes. And you can see there's your -1, there's your +8. Okay, there's your vertical asymptotes, which is where the function is undefined. So my function is undefined at -5/3 and 8. Okay, then it wants to know when is it positive. Well, again, you can tell, what you would do is you would test, okay, and I don't have any room. So if I test something below -5/3, let's do -2. So if I do f of -2, I'd have -2 minus 1 over 3 times -2 plus 5, -2 minus 8. This is going to be a negative. -6 plus 5 is a negative. That's a negative. So you have a negative divided by a positive, which is negative. So this section is negative, which I can tell from the graph. It's below the x-axis. Okay, but again, we're not supposed to be cheating. In a test type situation, I don't know if you're using the calculator or not. Okay, and then we need to test something in between -5/3 and +1, so I'm going to pick 0. So I'd have 0 minus 1 over 3 times 0 plus 5 times 0 minus 8. That's going to be a negative on top. 3 times 0 is 0 plus 5, that's a positive. 0 minus 8 is a negative. So you have a negative divided by a negative, which is going to be positive. So this section in here is positive. Okay, between 1 and 8, I'm going to pick, 2. So I'd have 2 minus 1 over 3 times 2 plus 5 times 2 minus 8. The top is going to be positive. 6 plus 5 is positive. 2 minus 8 is negative. You have a positive divided by a negative, which is going to be negative. And if I pick something beyond 8, like 10, I'm going to have 10 minus 1 over 3 times 10 plus 5 times 10 minus 8. That's a positive. 3 times 30 plus 5 is a positive. 10 minus 8 is a positive. A positive divided by a positive is a positive. Okay, so then it wants to know when is it positive then. I'm trying to see, they're using, and again, they didn't say or equal to, they're using interval notation. So it's positive between -5/3 and 1, union 8 to infinity. It's negative here and here, which you can't see it because I didn't copy it very well. So for D, C you can see. D, it is negative from negative infinity to -5/3, union 1 to 8. Okay? Alright. The x value that causes the function to equal 0. When you're finding your zeros, you set numerator equal to 0. Solve, square, square, x plus 8 equals 0, x equals -8. There's my 0, okay, at -8. I don't know why that's not on the graph. Oh, I know. I bet this stops at -8. You can't. Yeah, everything's going to have to stay bigger than -8. Remember my domain? Okay, my domain, this would say that you have to stay positive. So everything would have to be greater than -8. So whatever this function does, it stops there. And everything below there. Again, yeah. Alright, there's your 0. Okay, what values of the function cause the function to be undefined? You're undefined when you have denominators equal to 0, so 4x plus 2 can never equal 0, x minus 3 can never equal 0, and radical, the square root of x plus 8 must always stay positive. Minus 2 divide by 4, x can never equal -1/2. X can never equal 3. Square, square, you get x plus 8 greater than or equal to 0. Minus 8, x has to be greater than or equal to -8. So on my number line, I've got -8, that's a 0. I've got -1/2, that's undefined. I have +3, that's undefined. And everything back here is undefined. And the reason is because this says x has to stay greater than or equal to -8. So the whole graph has to be over here, which means all of this is undefined. So my 0 is at 8, and my undefined is at -1/2 is undefined, +3 is undefined, and anything less than -8 is undefined. So this whole section is undefined, and that's where they got this answer. Okay? Positive, we're going to have to check. Excuse me. I'm just going to actually look at the graph. Okay, in between here it's going to be positive. In between the -1/2 and the 3 it's going to be negative. And on the other side of 3 it's going to be positive. So the values that make the function be positive are here. And again, I hate that they're alternating between interval notation and I don't remember what this notation is called. Anyway, they're alternating back and forth between them. So if I do this, anytime you've got a between, all you do is put your letter in between it and point your arrows left. Okay? So it's positive between -8 and -1/2, and it's positive on anything bigger than 3. And where's the function going to be negative at? Well, that's right here, which is, and again, I apologize, I cut off the answer to D, which is between -1/2 and 3. Okay? Alright. It says solve the inequality using a sign chart. Alright, so if I solve this thing, I'm going to type it in the graphing calculator. Well, I mean, and what you can do is you can see that at 0 and at 3 you get your zeros, because if I set those factors to 0, I get x equals 0. This would be plus or minus 0, but 0 doesn't have a sign, so this is just going to be x greater than, or not greater than, x equals 3. So my zeros are at 0 and 3. And if I did it 0, 3, and did a sign chart, without cheating on the graph, if I pick something below 0, let's pick -1. So if I do f of -1, I'd have -1 times -1 minus 3, not the absolute value. And if I solve that, I would have -1 times the absolute value of -4. The absolute value of -4 is 4, which gives me a -4. So this section is negative. Pick something between 0 and 3. I think I'll pick 1. That's going to be 1 times the absolute value of 1 minus 3. That's 1 times the absolute value of -2, which is 1 times 2, which is positive. And if I pick something beyond 3, like 4, and find f of 4, I would have 4 times the absolute value of 4 minus 3 greater, or sorry, you're just solving it. That would be 4 times the absolute value of 1, which is 1, which is positive. And again, it's because of that touch and turn. So, now what are they wanting to know? They want to know when it's greater than, not or equal to, just greater than 0. So if I can include my zeros, it's this section and this section, which starts at 0, goes to 3, starts at 3, goes to infinity. Okay? Alright, squares are cut from the corners of a 10-inch by 13-inch piece of cardboard. The flaps are folded up to make an open box with volume not more than 95 inches cubed. What size squares should be cut from the cardboard. Okay, well, we're talking volume, which is length times width times height. My length is not 10 anymore. It was 10, but they took off an x on this side and an x on this side. So that makes my width 10 minus 2x. This was 13, but it's not anymore. They took off 2 x's, so this is 13 minus 2x. And the height of the box would be x, because that's the size of the flap. So I have the volume equals 10 minus 2x times 13 minus 2x times x. Okay? So, and we want the volume to not be more than 95 inches cubed. And again, I apologize. I should have already graphed this for us. So basically, we want to keep this smaller than or equal to 95. Does that make sense? Okay, so if I go to y equals and I type 10 minus 2x times 13 minus 2x times x, and for y2 type 95, adjust my window to go from my y's. I don't need to see the negatives, so -2, I want to go to 100 and count by tens, and on the x's I really don't need to see -10 to 10. Can't, I mean, the x can't be bigger than 10 because you'd only have 10, you couldn't cut anything off of it. So for my x's, I'm going to go from -2 to 5. And when I graph this, I get this, there's my 95 line, and I get this parabola that does this. Okay? So, sorry, there's two answers here. So choose an approximate interval for the smallest possible x values. So if I want the smallest possible x values, I'm looking for when it is below this 95 line. So from here to here. Yes? Alright, so we've got to get those intersection points. So if I calculate intersection, and I do my first curve, second curve, enter, this intersection point is 1.156, 95, and that's where they got the 1.2. Okay, and then this intersection point, I'm going to get over a little bit, enter, 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 and this intersection point is 2.68, blah, 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 so let's call it 2.7, 95. Okay, so we've got those intersection points now, right, where it is smallest x possible values, okay, is going to be in between this section. Hold on. Let me change my window here a little bit. Well, son of a gun, see what I get? Alright, so see, it's a good thing I can see the answers, because I'm like going, where is that coming from? Okay, Smarty Pants, your teacher thought that going out to 5 would be good enough. It actually, when I go out to 10, it does this. It comes up, comes back down. Actually, it doesn't come down that much. It comes up. Here's your 95 line. Oops. What the heck? Sorry, I wanted another color. Here's your 95 line. That's y equal 95. The graph, if I go out to 10, comes up, comes down, and comes back up. Okay, so this point was 1.2, 95. this point was 2.7 comma 95. And this point, if I calculate it, I get over here, enter, 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 is 7.7 comma 95. Where in the heck is the 5 coming from? Hold on, let me check my 10 minus 2x, 13 minus 2x, and x. This point right here is at 5. If I calculate the 0, there it is. Right there's your 5. So it crosses at 5, 0. Okay, so let's see if we can make sense of this. All right, the smallest possible x values. Well, here it's less than 95. Here it's less than 95. And here it's less than 95. Hold on, let me pause while I ponder this. Okay, I figured it out now. Okay, that was painful. All right, so my picture's not very good either. Okay, so I get it now. The smallest possible x values. Again, we're looking at this section right here because up until here, I won't go over 95. Okay, so these are the smallest x values that would give me a volume lower than 95. What the heck? All right, whereas over here, if I look right there, in between there, you're going above 95. But beyond that, until the 0, okay, these are bigger x values that still give you a volume less than 95. Okay, so these are the largest x values. These are the smallest x values. So your smallest ones go from 0 to 1.2, which is where they're saying your smallest intervals are in between here, which is 0 to 1.2. Dang it. Whereas your smallest one, your bigger ones are over here on this side, okay, and that would be in this interval, which goes from 2.7 to 5. Again, my graph isn't, this should be farther apart, but this is the gap between this x and this x. So again, x is between 2.7 and 5 is where your largest possible x values are. Okay, that one was a little rough. Alright, that makes us done, and happy studying. See you next time.